Hi Spring fans, welcome to another installment of Spring Tips. In this installment, we're going to talk about reactive SQL-based data access. So, of course, if any of you have been following along, we're talking a lot about reactive programming of late, and for good reason, because it gives us a way to describe potentially latent, potentially asynchronous input and output, asynchronous I/O, and to provide a sort of a wrapper, types that we can then use on top of that asynchronous I/O foundation to model the world, to think about the world, to think about the integration between components in the world. And when we move to reactive programming, when we move to asynchronous-based programming, we need to be aware of the fact that data is potentially unlimited. That data will be, that the bytes that we are sending on a channel, for example, are going to be sent, and we might get the acknowledgement later on. And inversely, that the data that we expect from a read may arrive in a nanosecond, or it might just as well arrive in a week, right? It's asynchronous, it's latent, it's potentially unbounded as well. There might be a lot of it, and so these ideas make it so that we can now write code that monopolizes threads as little as possible. And the benefit of that is that we can move input and output to the sort of asynchronous I/O mechanism for your platform, and that channel, that mechanism can handle the work of moving data back and forth across the buffers, and only when there's actually processing to be done on the data do we then get moved back into a thread. And the reason this is so valuable is because threads are expensive. They take up a lot of actual RAM, like resources in the computer. They're hard to schedule efficiently, right? So it requires a lot of input and output, a lot of work, really, beyond the input and output to use threads efficiently. So we want to repurpose our existing threads, because they're precious and there are a few of them, as often as possible. Asynchronous I/O and reactive programming, which builds upon asynchronous I/O, enable that. So people are excited about this. They want to move to reactive programming, and for a long time we've talked to people about how you have some good options when it comes to persistence. Certainly, right? We've seen that the Spring team has already debuted Spring Data, and Spring Data Spring Data K and greater have supported reactive data access options, including options for Redis, reactive Couchbase, reactive Cassandra, and reactive MongoDB. And these are not just, in most cases, not just reactive equivalents of what you have in the synchronous and blocking alternatives. No. In many cases, you are actually given more features because of the foundations of the implementation being based on this asynchronous reactive driver that we use instead. So instead of using the synchronous and blocking driver that underpins, for example, the regular Spring Data MongoDB, we use a completely different driver which supports asynchronous I/O for the Spring Data reactive MongoDB driver. And so we can do some things that are just not as easy, not as elegant, not as clean. Alternatively, one example in MongoDB, for example, is tailable queries, which just works out really nicely, right? MongoDB is a great example of a database driver that is better, I think, for the use of reactive programming. Now, I gave you that list of supported reactive database options, and you'll note that I didn't mention a SQL data store, and that's because up until recently, there wasn't really a lot of good options here, a lot of good choices. We had what I would have to charitably call an optimistic effort at supporting asynchronous database access in the Oracle ADBA effort announced in 2016. That was certainly more than 2 years ago, right? And that effort has come some ways in the interim, but it's not anywhere near GA. And then contemporaneous with that, I suppose subsequent and then contemporaneous with that effort is our R2DBC project. And R2DBC is an open source project that we have here, github.com. R2DBC is a reactive relational database connectivity API, and it is meant to provide an SPI, which you see here, and then several implementations of the SPI built on, where appropriate, natively reactive or at least natively asynchronous drivers, and we then surface that as an implementation, right? A binding, if you will. And we have, to wit, now 3 interesting bindings. We have PostgreSQL, we have H2, and we have just recently the Microsoft SQL Server implementation. And knock on wood, hopefully there'll be more to come. These are based on actually asynchronous drivers, right? Different drivers, and they are the first of what we hope will be many, right? We also have a R2DBC over ADBA. So if ADBA ever becomes prolific and people want to adapt that, that's fine. We expect that R2DBC will be a foundational library on top of which other things, other more convenient abstractions will be built, right? In the same way that JDBC is not something that most people interact with directly. There's usually some sort of intermediary layer. If nothing else, there's something like the JDBC template, right, which makes work with that lower level SPI more palatable. So R2DBC is, if nothing else, a fundamental approach at a fundamental take on reactive data access for SQL-based databases. It is an SPI and it is a foundation. We want it to be as interoperable as possible, so if ADBA ever goes anywhere, if it becomes useful, we'll be ready. And hey, who knows, maybe ADBA will become the perfect implementation, in which case that would hopefully moot the use of R2DBC. So maybe this would become just a thin wrapper on top of that. I don't know. That's why, for the moment at least, this is not a recommended for production sort of thing. But it's certainly interesting, and I hope you'll consider feeding back into it. We've got a lot of people working on this, so we certainly hope it's in for the long haul. But we're open to being wrong. We're open to having this be just an inspiration, right? Okay, so with that in mind, what we're going to do is we're going to use some of this new stuff. We're going to use it directly through R2DBC. And then we're going to use it through a brand new project, which is the reactive analog to yet another new project, both of which we announced at Spring Run Platform 2018. The first is Spring Data JDBC. Now, Spring Data JDBC is not a new project per se. It existed hitherto as a open source community effort that was separate and apart from the Spring, the Spring portfolio projects, officially from Spring-projects on GitHub, and that's a very interesting effort that's been now officially folded into the portfolio of projects, and I encourage you to take a look at that for your synchronous and blocking SQL data access needs. We also have Spring Data R2DBC, which, as you can imagine, just as with Spring Data JDBC, integrates the sort of underlying JDBC, or in this case R2DBC SPI, to provide Spring Data idioms like a template and well, in this case, a client, and also support for repositories. So we're going to take a look at that. We're going to take a look at both those projects, R2DBC and Spring Data R2DBC, in today's installment of Spring Tips. So in order to do that, we're going to build a new project, R2DBC, and we're just going to use Lombok, and I'm going to use, well, I suppose that's it. I guess that's all I really need to demonstrate everything. We're going to bring in Reactive Web, just because it's nice to have a Reactive Web endpoint, I suppose. That's easy enough. But everything else we're going to have to add manually. So I'm going to use the latest and greatest Spring Boot, and then we're going to manually change the build, the Maven build to have the dependencies that we want. Alrighty, so that's going to open up, and the first thing that we're going to do is add the milestones repository. If you haven't already done that, if you're not already using a milestone version of Spring Boot when you generate the project, then you'll want to do that, right? So deps R2DBC db copy, and I'm going to go to my build. Okay, so what do we got? We got that's the repository that we need. We're going to put that in the repositories tag. Okay. Paste that there. Oh. Okay. Paste this. And these are the dependencies that we need for R2DBC. So we'll paste those in here. All right. So Spring Data R2DBC, this is the latest and greatest. This was just announced about a week ago. And here's R2DBC Postgres. This is the driver for Postgres. As I said, there are a couple of versions. This is the one that I know to work well with Spring Data R2DBC. So we're going to use that. And in our code, we're going to start with low-level R2DBC. In order to do that, in order to start any of this effort, we need a connection factory, don't we? We need to actually have a connection to a Postgres database. So I am going to build a connection factory configuration. And again, I expect that this will be one of those things that's best handled for us by Spring Boot one day, hopefully soon rather than later. And Spring Boot could auto-configure the connection factory just as it auto-configures the data source for us today, right? So I'm going to, fingers crossed, that'll be a thing we can enjoy in the future. Now, a very natural thing to do would be to, knowing that Spring Boot will one day probably support it, and it'll probably do so in a way that's familiar and compatible with what we're already doing. You could put your connection string, your R2DBC connection string, in a spring.datasource.url, and then inject that into your code somewhere manually, so as to, you'd actually inject it using a property like so, add value, and spring, .datasource.url, string URL. Okay, so that's one option you could do. I'm just gonna hard code my username and password here. I don't care. I've got it in my local machine. If you were injecting that connection string, you'd have to pick apart the information, I trust you can do that. Just use the JavaNet URI. On the other hand, I'm going to do this the old-fashioned way. We're going to return a new connection factory, and this is going to require some configuration. The config object, we're going to extract out into a local variable there, and it'll say Postgres connection factory .builder.build. I'm going to say .builder.database orders password password will be orders, okay, username orders, and that's it. I think database host, localhost, okay, and that should be it. That's the configuration for the connection factory. Now, for now, that'll get us started. That'll give us a basic R2DBC machinery. We might also want a database client that works with that, and the database client is a object that that supports reactive data access through R2DBC, and it's sort of like the analog to the JDBC template in the reactive world. You notice that we've moved in certain cases from template objects to client objects. So in the reactive web domain, we've got the Spring Webflux project, and then there we have a web client rather than a REST template, right? And now we have the database client instead of the JDBC template. So that's kind of a new thing. Okay, now we need that database client, so we'll build that here. And here we can just use the builder, just as before, connection factory. There we are. Now, we'll see later that we can actually comment that out later, but for now, we're okay. Now, what I want to do is I want to build an application that works with and manages entities of type reservation. Can you imagine? And my reservation is fairly familiar. You've seen this a million times, I'm sure, if you've ever seen my talks. So ID, private integer ID, private string, we're just going to call this name. All right, so there's my thing. It's going to be using Lombok to create the getters and the setters. Goody. Okay, there's my three fields. From there, we're going to write some data to the database. I'm going to create a repository manually here. I'm going to do this the old-fashioned way. We're going to write our SQL by hand. I know, gasp. But the benefit is that we can see some of the low-level R2DBC SPI or API, and it really isn't so bad. It's actually quite approachable. Certainly as approachable, if not more, than regular JDBC, which, to be honest, for what it does a fine job as well. So no need to be sour on either. I've always been a big JDBC fan. As you know, from some of the other videos we've done in the Spring Tips series, we've done videos that looked at MyBetas, for example, and we looked at Hibernate, and we looked at Java OOQ, the Juke project. So lots of different efforts to support and make easier the work of using JDBC, but ultimately I think JDBC is pretty powerful. Okay, so we've got this, and of course in other videos we've even looked at the JDBC template. I've done a couple of videos looking at cloud platforms actually, and there I introduced how to talk to a SQL database in terms of the JDBC template, because why not? So here we have a reservation repository, and this repository is going to support a few of the usual things. It'll support a delete by ID. I suppose it'll be an integer ID. Okay, we'll come back to that. And it'll support returning a publisher of reservation, like so. Okay, and it'll support returning a saved reservation. Okay, we'll come back to that. All right, so I think, and then we want to delete by ID. We've got to find all, and we've got to save. Okay, so now let's just implement one of these, and I suppose we could start with the more fun one, which is like the find all. I always love doing queries because, you know, who wants to put data there? It's much more fun to read it out and to work with it. So we'll start with that. I'm going to need a connection. Okay, so I'm going to need a connection to be able to do this. So I'm going to vend a connection here, and I'm just going to have a little finder method here, a little convenience method, private mono connection. Okay, and here mono.from this .connection factory .create. Okay, so there's my my connection. I'm going to say this .connection, and what I want to do is I want to find all the results. So I'm going to say, with the connection, let's process the data and go through the results. So flux.from connection.create statement, select all from reservation. Okay, and we're going to execute that query, and with that oops, wrong one. Flat map many from this .execute .flat map. Okay, we're gonna have a row, and what we're gonna do is we're gonna say row.map, and this is kind of like the row mapper in the JDBC template. Row.map. I guess we can just call this R for ease of dereferencing. And when we have that, we're gonna lambda, so it's gonna be row and row metadata. It's gonna be metadata about the row, and we're going to process all of that and turn it into a object. So row dot get. And does this look fairly familiar? This should look like the row mapper. If you ever use the row mapper in JDBC template, we're given a pointer to the current result set and the current offset, right? The index on in the result set. Very similar to the row mapper contract in JDBC template in Spring's regular JDBC support. But this is, I think, wiser for all the sort of use cases that with which people might have become familiar over the years. So here we're going to return an integer.class for the ID, and we're going to return a row.get name. That's going to be a string.class. Okay, so what's happening here? We're saying when somebody makes a connection, use the connection, and when we have the connection, we want to create a result set from that. Right? We're going to execute this, and that'll give us a publisher of results. And then with each result that we get back, we're going to flat map the results because it's reactive. It's a publisher, so we're going to dereference we're going to unpack the intermediate publisher and then visit the results themselves. And so for each result R, like this, for each R2DBC result R, we're going to map the result given the row and the row metadata into a reservation object, and we're going to do that by unpacking the relevant columns in the result object into the constructor of my new reservation. And the result of that will of course be a flux of reservation, right? That's the contract here. So that is fairly straightforward, right? We're just reactively row mapping the data, which I love. Okay. We want to then save some data. So let's see. In order to save a reservation, we want to say that we want to say this dot connection dot flat map many, and what we're going to do is we're going to say, given the con, create a statement, and we're going to insert into reservation name values $1. Now $1 is the it's the way we bind in Spring Data R2DBC and R2DBC in general. So we're going to say bind $1 c.get r.get name. Okay. And then we're going to add this to the database. We're going to execute. Right. So what does that give us? That gives us this. It gives us a publisher of results, and then we're just going to switch. We're going to map each one of those and write it out. Okay, so there's our data. We can actually just say return flat map many dot switch map, I suppose, and return R, and just return a publisher. Let's just do that for now. Okay, new reservation r.getID x name. Alright, so there we go. There's our save. That's pretty straightforward. What else? Well, we need to do a delete by ID, don't we? So here, this dot connection, this one's easy. This one we just say flat map many c, and then we're going to say c dot create statement delete from reservation where ID equals 1, and we're going to bind .1 to ID. We're going to say execute, and then we'll say then. Give us a mono void. Simple as it can be. Okay, so there's our simple repository. We've got the entity, we've got a connection factory. That's all we need for regular R2DBC. Now let's go ahead and test this code. Let's actually write a bit of code just to exercise this. And so what we're going to do is we're going to create a reservation repository test over here. Okay, and we're going to use the reactor context test support. Okay, so we'll say spring boot test run with spring runner dot class. Okay, and we're going to inject the reservation repository like so. Create a test public void all. We'll just do everything just to really test everything. Probably a bad test, but we just want to demonstrate everything's working. So let's say this dot reservation repository dot find all dot flat map r, this dot reservation repository delete by ID r dot get ID. So I'm now testing that. Okay, that's one thing. I want to verify that that works. I'll use the step verifier. I'll say create delete void flux. That'll be called that, but I'm going to rename it to delete all. Okay. Dot expect next count will be, let's say 0. Dot verify complete. Good. And then we're going to say we want to write some data to the database. So I'll say flux.just, and I'm going to write some emails. Let's say or just names, I guess. So first, second, third, and then I'm going to map each one of those names into a new reservation. Null name. And I'm going to map each one of those into a written data point. Save R. Okay. There we go. And I want to verify that we have the expected amount in the database. Count is 3. verify complete, great. And then finally I want to get all the data and just confirm that it's working as we expected it to. So dot all. Good, there's that. And we're going to say step verifier dot create all dot expect next count 3 verify complete. There we go. There's all three of them. Very simple. Those are three methods in being exercised a little bit here. I suppose I could have extracted these out into separate tests, but I just wanted to see that all work. So let's go ahead and hit run with what we've got. We should be okay. Oops. Semicolons are required. This isn't Kotlin after all. Did we work? Come on. Here we go. Cool, that worked. That's green. I suppose I should show you the database, right? So pSQL minus u orders. Delete. Let's try it again from reservation. Right, I got rid of 3 records there. We're going to run the test again. Okay. Select all from reservation. And there we go. So there's our records, right? So that's working. That's fine. That's basic R2DBC, very low level, but not so bad. I think it's fairly functional. It's really clean, really easy to work with, and that's great. Now, we need to go a step further, don't we? We need to go a step further. So let's now use the Spring Data R2DBC project. So what I'm going to do is I'm going to comment out this repository, helpful though it's been, easy enough and succinct enough though it is. We're going to comment that out, and we're going to use Spring Data R2DBC, and that will make our life significantly easier, right? As though it weren't easy enough somehow. So I'm going to leave this here. This is fine, but we don't actually need this. And I'm just going to create another configuration class, but there's no reason that it couldn't be the same, or in the main configuration class. Extends abstract R2DBC. I'm going to override this method, the connection factory method. In order to provide that response, that bean, we're just injecting the connection factory that we've already created into the constructor. We say return this dot connection factory. I'm going to say at configuration at enable R2DBC repositories. All right. So there's that. That's the hard work that we have to do. We need to annotate our thing, our entity. It's got ID, so we're already halfway home. And then we need to create a new repository, don't we? So we can do that pretty easily. We can say interface reservation repository extends reactive CRUD repository managing reservations whose primary key is of type integer. And that's it. That's the configuration for R2DBC. We need that for the moment. Hopefully one day in the far-flung future, the auto-configured. I mean, this is not really hard at this point, right? But it's still code that I can easily imagine Spring Boot doing for me, so that I can just create this interface and this entity and be on my way. We can go back to our test. All right, how's that? So we did good. Look at that, huh? There's our simple test. Everything's working just fine. We should have. Let me delete the data just in case. There's that. Run that again. Oop, there we go. So there's our data. So you can see that this is a nice, easy way to get a reactive SQL-based repository. Obviously, this is you can create custom queries as well. So I could say find all the reservations by name, string name, right? It doesn't support auto derivation of queries based on the method names yet. So in order to do that, you'd have to say at query select all from reservation where name equals 1, right? And then we could actually test that out here. We could actually now say this dot reservation repository dot find by name, and the name will be first. I'm going to assert that'll give us a result. I'm going to say find the first. We're going to expect 1 to come back and then verify it's complete. Okay, so that's our custom query. Let's see what that looks like. All right, not bad, huh? So we were able to get one result back. We found the one result we expected. This makes life easier. Now, we have a long ways to go, I think, before this is all like, this solves every problem for everybody, of course. It's not going to be tomorrow, but there's a lot of interesting possibilities here. You can now do reactive SQL-based data access. We get the benefits of reactive programming. One thing that's kind of interesting is to watch the interoperability options here. We can actually there are projects out there that are aiming to support integrating, for example, Zipkin and distributed tracing and Micrometer for metrics accumulation with these projects, right? There's already connection pools that are being developed to support this. I mean, there's all sorts of interesting stuff happening in and beyond the R2DBC projects and the ecosystem that is created around that. So it'll be interesting to see where this goes. I think this API is really convenient. I like the R2DBC API by itself. I like the reactive Spring Data R2DBC support as well. And you can see I was able to just drop in. I just commented that out, just added the ID annotation, and at enable, I had to create this boilerplate configuration here, but this is not a big deal. So really the full footprint of the code that, the mental overhead that I had to pay. And I got all that stuff I did for free. I got that same thing. I got the find all and the delete and all this stuff. I got that for free, and I got this new method, which is a custom query, which maps nicely to this parameter with almost no effort at all, right? No mapping, no queuing up a connection or anything like that. So I like this approach. I hope you like it too. And obviously, this is a very natural fit with Spring Web Flux. So if you wanted to stay reactive end-to-end from the database tier all the way to the web tier and through the security layer and all that stuff and back again, you could do that now. You can actually have a Spring Web Flux endpoint that served up this data, and also you could use this in conjunction with RSocket, the protocol developed by Facebook that supports reactive interoperability. It's a wire protocol that has at the moment at least 3 different clients: one in C++, one in JavaScript, and of course one in Java. Powered by Reactor, and you can use that to do fire and forget, request response, pub sub, and full bidirectional multiplexing and streaming. I mean, you can do all sorts of interesting things, and there's built-in support at the protocol level for communicating availability. So you can use this, technologies like R2DBC and Spring Data R2DBC with technologies like RSocket and with technologies like Spring Web Flux to get a completely end-to-end reactive stack, on what we might have thought of as being sort of traditional APIs. All right, so my friends, thanks so much for that. I hope you got something out of this. As always, thanks for watching, and we'll see you next time.